So alright, so this time let me make a quick introduction about um see like this question you always get like graphing. Alright, so graphing. Alright, so like I know you guys have this type of question that it gives you like a graph of position, a graph of velocity, and then a graph of acceleration. It ran like one graph, right? They give you one graph and like tell you that get the other two graphs. And people get confused. Right now, like I will explain you how this works. Right. So let's say our first question is what if like it gives you acceleration that's like that, and then let's just fill out v and s. Well, what do I do? See here. Like now, so we assume that v starts from 0 and x starts from 0. And you can mostly figure these like starting point sections. So we see a is a constant. It's a number. It's a constant. It's no like function. Whatever is not moving is not like increasing, decreasing, changing. Nothing. It's a constant. So what is a? What is the acceleration? Acceleration is the rate of change of v. So if a is positive, then v has to be increasing. Because like if acceleration is positive, then like speed is speeding up, of course. Right. So since a is a constant, v increases in a constant rate. So v actually increases in a straight line like this. Alright, cool. So v is increasing from straight like in the straight line. So what's the x gonna do here? Well, part comes. Alright, so we say observe a graph of this, and you probably will say, "Oh, x is probably increasing." Well, yeah, x is increasing, but how is it increasing? We see here, v at this starting point. What is the v? It's 0. What does 0 velocity mean? It means the object is not moving. So right here, x is not moving. It's in like a straight line. It's a horizontal line. It's not moving. Alright, so v starts pretty slowly, but you notice here, v is really small and v gets bigger and bigger and bigger and bigger and bigger. What does it mean? It means the object is getting faster, 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 faster. So how do I make the object faster? It moves like this and get faster, 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 faster. That's how it moves. Make sense? Alright, so let's do another question. Let's do another question. Let's do what am I even doing? Alright, cool. Let's do another question of let me like here. Let's say the v is moving like a straight line like this. Then now we can actually figure a out because v is decreasing in a constant rate because it's a constant rate. So a is a constant, and since it's decreasing, a has to be a negative constant. So a is something like this. So what's x gonna be? Well, again, let's see. The initial v here, v as a starting point, is 0. What does 0 velocity mean? Again, the thing is not moving. What if, what's the particle gonna do? So object gonna do? The object's not moving, it stays. So how do you represent the thing if it stays? Then clearly it's not moving, so it's like in the horizontal. Right here, let's change the color. Change the color to like green. Yeah, right, cool. It's like this, right here, in this interval, like in the original point. So v goes down, 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 down. You may think v is going slower because it's going down, but no. Speed. It's actually speeding up because it's going toward negative, and then the v is getting more and more and more negative. So this thing is actually speeding up, but the velocity is going to negative. So this thing is actually going down. So we can like imagine like this is like just like a person, and then like there's like a little bug right here, right here, right? Cool. So instead of moving like instead of moving ahead of the person, it moves like behind the person, like this. That's a negative velocity. So what's x gonna do? X gonna start from 0, from a velocity, and it's gonna speed up, going down, up like this. Alright, cool. Let's do some crazy stuff here. Some real crazy stuff. Like this is probably gonna be the hardest question you get of these graphic questions. So again, this is x. Sorry, my y-axis kind of twisted, but don't worry. This is v and this is a. So what if the v velocity starts from here, goes up? Also, you know, it goes up like constantly, like this. Whoa, I've seen that. Alright, cool. So what's gonna happen is moving up in a straight line, constant acceleration. So as this is moving up, it's increasing. So the acceleration has to be positive, a constant positive number. It's like this. So here's part. What's x gonna do? Oh, again, let's analyze this. So first of all, the v starts from like a really negative number. Let's say this is a starting point of x, right? So x is gonna start from like a really negative velocity. So x is actually going down like this, right? Because it's negative velocity, so it has to move down, right? Right. So during this entire interval, you notice the velocity is negative. What does a negative velocity mean? It means you're going away negatively from what? So it'll move like this, and notice the velocity is approaching 0, so the speed is actually speeding down. It's actually slowing down. So it approaches 0 velocity. And what does 0 velocity mean? It means the object's not moving. So here the object's not moving. Here, during this interval, it speeds up again, but this time positively. So it actually speed up like this. So like assume like again this is like a person right here observing, and then there's a little bug thing right here. This person is this way. What does this even mean? Alright, so this means it's a bug and moving away from the person natively, and then it slows down, and then halts right here, and then it comes back to this person. That's what it means. But you probably say, why? So why is the acceleration constant? Because this guy right here, he starts with a initial velocity like this. The acceleration is always constant. It's actually pulling it back. It's actually pulling it back little by little until it gets here. That's the new velocity. Alright, so yeah, this is a little short class about graphing, and hope you guys enjoyed it. I know it's pretty hard to enjoy physics, but I mean, yeah, you gotta know it. Okay, so cool. I'll see you next time.